Hi everyone. In this video, we are going to do a quick introduction to logarithms. So for any number a, b, and c, we have the following equation. Log base a of c is equal to b if and only if a to the b is equal to c. All right, so here we have a is the base of our logarithm here. Okay, that's important terminology that we'll need later. And so given this equivalence here, um, given this equivalence, we're going to see if we can use this to maybe rewrite a few expressions. So here we have log base 8 of 1/64 is equal to -2. All right, so let's go ahead and identify each part here. So here we have a is equal to 8, b is equal to -2, and c is equal to 1/64. Let's rearrange this using our exponential form, and let's see if we can make sense of this. So if we have a to the b is equal to c, then if this logarithm was set up properly, we should have 8 to the -2 is equal to 1/64. All right? Well, if we have 8 to the -2, 8 to the -2, that's the same thing as 1/8 squared. And we know 8 squared is 64, so we have 1/64. So there we go. That works out. All right? What about this one? Here we have 3 to the 0 is equal to 1. So here we can say a is equal to 3, b is equal to 0, and c is equal to 1. And let's see if we can write this in log form. All right? So looking back up here, we have log base a of c is equal to b. Log base a of c is equal to b. So we could write this as log base 3 of 1 is equal to 0. All right? What about this one? Log base 2 of 1/16 is equal to -4. Can we write this as an exponent form? So a equals 2, b equals -4, and c equals 1/16. So a to the b is equal to c. So we have 2 to the -4. 2 to the -4 is 1/2 to the 4th. And 2 to the 4th is the same thing as 16. So we have 1/16. So this logarithm makes sense. How about this one? Can we write this 5 to the 2 is equal to 25. 5 squared is equal to 25. Can we write this as a logarithm? Here we have a is equal to 5, b is equal to 2, and c is equal to 25. So we can have log base 5 of 25 is equal to 2. All right, so we can see that we can go back and forth quite easily here between exponential form and logarithm form. So given that, can we see if we can solve some of these logarithms here? So what about log base 9 of 1? What is that equal to? Well, we have a. We have a is equal to 9, and we have b. We don't know. We don't know what b is. So we'll say b. We don't know. Maybe we can say that b is equal to x. So we'll say x. All right. And we have c is equal to 1. So we know that a. So then we have, since a to the b is equal to c, we have 9 to the x is equal to 1. So what value of x would make 9 to the x equal to 1? Well, we know that anything raised to the 0th power is equal to 1. So we could say x is equal to 0. So we know that log base 9 of 1 is equal to 0. Okay? So now let's take a look at this one. What about log base 7 of 49? So we have a is 7. We don't know b, so we can say b is equal to x again. And we can say c is equal to 49. So we have 7 to the x is equal to 49. So what value of x will make 7 to the x equal 49? Well, we know 7 squared is 49, so we can say that x is equal to 2. Therefore, log base 7 of 49 is equal to 2. What about this one? Log base 7 of 1 over 7. All right, well, again, we have a is 7, and we have c is 1 over 7, and we don't know b, so we'll say b is x. So 7 to the x is equal to 1 over 7. All right, and we know that x will then be negative 1. Okay, what about this one? Log base 3 of 27. So here, we can do 3 to the x is equal to 27. All right, well, we know 3 squared is 9, so therefore 3, if we multiply 9 times 3 again, we get 27. So we can write x is equal to 3, and therefore we can have log base 3 of 27 is equal to 3. Okay, so these are really pretty simple. Really, all you have to remember is this basic equivalence here. We have log base a of c is equal to b if and only if a to the b is equal to c. And you should be able to solve most basic logarithms that way. But there is a special case here, and this is when the base is equal to e. So when a is equal to e. Now, e is a number that you see pop up all over the place in math. It has to do with a certain type of growth, and if you continue on in math, you're going to see this in calculus later on. This is a really important number, especially if you go on to calculus. But we're not going to cover it in too much depth here. The only thing that's important to know here is that e can be written. It's just an irrational number. An irrational number is some number just like pi that the decimals never terminate. Okay, it keeps going on and on and on and on forever, and it's non-repeating. Okay. So it's an irrational number. It can't be written as a fraction. All right, so when the base is e, we don't write log base e, we write ln, or we call that the natural log, okay? We don't write ln, we call it the natural log, okay? So let me turn this off. Okay, call it the natural log, and therefore we say ln of c is equal to b if and only if e to the b is equal to c, okay? So let's see what happens if we have e to the y is equal to 8. Okay, so we have e to the b is equal to c. Can we write this as a natural log instead? Okay, so let's write that down. Ln, okay, ln of c. All right, well here we have b is equal to y, and we have c is equal to 8. Therefore, we have ln of 8 is equal to y. Okay, that's just how we would convert that. Can we go the other direction? Ln of x is equal to 5. Okay, well, we have that b is equal to 5, and c is equal to x. Therefore, we have e to the 5th is equal to x. Okay, so there's a quick introduction to some basic log rules, and hopefully this will be of some help as we go on to more difficult topics involving logarithms.